Okay, this is number 17, page 337. Our first hint comes from the fact that JK is tangent to circle P and circle Q. So that means if I draw in a radius to the point of tangency, yes, it creates a right angle. So if I draw a radius from P to J, that's a right angle. If I draw a radius from Q to K, that's a right angle. So what kind of a shape must this be? Looks like a trapezoid, right? Because now if these two are perpendicular, that means that these are parallel. So I have obviously a quadrilateral. I have one pair of parallel sides, so this thing is a trapezoid. That's correct. So I'm supposed to be finding JK. So let's put an X there because I don't know what that is. Okay. Good golly, Miss Molly. What in the world could we do? Gosh, if only we had just done a whole big chapter on right triangles, right?
Well, wait a minute, we did.
So I bet you we could do something with a right triangle here. Well, before we keep going, there's something else that I know in this diagram that's not marked yet. There's other things that I know. Yes, Dakota. Right. Yes. So see how this radius, let me cover that up. Isn't that a radius of that circle? And that's 11. So doesn't JP also have to be 11? Every single radius in this circle is going to be 11. So that's helpful. And the same thing happens over here, right? That radius is 3. So then so is QK, right? Every radius is going to be congruent in the same circle. Okay, that's helpful. So now, we were just mentioning right triangles. Okay, so check this out. I have two right angles right there. What if I did this? You ready for this craziness? What if I did this? And I drew a line that was perpendicular to this. So now I had a little rectangle here. If this is now a rectangle and JK is X, isn't this purple line that I just drew also X? Yes, so that's also X. Keep in mind, I know it's not drawn to scale, it doesn't really look the same, but if QK is 3, what is this thing? Also 3. So if the whole thing was 11, that means that this little piece would be 8. Are you with me so far? Now look what I have. I've got a little right triangle on the side. And don't I have two sides of it, so can I find the third?
Absolutely.
Yes. So, looks like this short side is 8, obviously, and then my whole hypotenuse is, what's that, 17?
Yes.
17. So, if that's 8 and that's 17, then this side must be?
15.
Sweet. 15. 14. I have about 30 seconds. Yes, I can, because that one's super fast. So, 14, you end up finding out that AB plus DC equals AD plus BC. So they asked you to find out what's true about that and that. It's that they're equal. Here's why. Remember, don't look at any of these other red lines. Just look at that right there. Aren't these two little things equal to each other? From A to wherever it's hitting right here. Those, right? That's the ice cream little thing. So then over here on B, I know it's so teeny tiny. Those two little pieces are going to be the same. Then on C, these two little pieces are the same. And then D, these two little pieces are the same. You follow me so far? Okay, so what you could do, I have no idea what they all are. Yeah.
How do you know that?
That was the theorem in 9-2. Or not, yeah. No, 9-2. We learned that in 9-2.
It's like the color.
That's this. If you have two things, two segments, and they're tangent to the same circle, they're equal to each other. So, then you can get there, that they're all the same. Is that all right? Okay. Anything else super fast? We need to do something from 9.4. Did anybody get to 9.4 stuff yet?
Yes.
What number? Yes. Oh, that's a good one. I'm going to go over my 1 o'clock rule. We'll have to hurry. Okay, so, but that one kind of sums up everything that I want to talk about, so that's a good one. Let's draw a nice big circle. So, in 27, if you haven't gotten there yet, you will. So, you have one circle with a diameter, and then you have these two other chords. One's there, and then one's there. Something like that. Well, all right, 27, page 348. Okay, the center is O. This is point Y right here. And this is point X right here. And you are supposed to find the length of chord XY. So literally that. That's what I'm looking for. And they give me, what, a couple of things. Well, first of all, I know that these chords are parallel to each other. So that's important. All my chords are parallel. Got it. Their lengths are 20, 16, and 12. So the top one's 20. The whole thing's 20, which means that each piece would be 10. So you're 10 and you're 10. Agreed? This next one is 16. But I don't know where the middle is, right? So I can't just divide it up. Or can I?
Just go straight down.
Exactly. Didn't we learn that a radius or a diameter that's drawn perpendicular to a chord will bisect it? So that's exactly what I'm going to do. I'm going to drop, because you're allowed to draw in a radius wherever you want. So just draw a radius so that it's perpendicular to these guys and that one. They're all perpendicular. So now they all just got bisected. So the one that was 16 is now 8 and 8. And then this one was 12, so you're 6 and 6. Okay. I still don't know what XY is. However,
Like a line.
where?
Like from point X up to the line Y.
Oh, like this?
Yeah.
That's not a bad idea. So now I have this little mini rectangle, so that's now 6, and then this little piece is 2. Does everybody see that? Is that okay? I like that. And now I have a little right triangle here, and if I could just find this piece, I could find the hypotenuse. Agreed? Okay, cool. So, that's what I need now.
You do cosine, tangent, and stuff like that? Because you know that one side's 2, then the angle's 90.
You need one of these angles. Yeah. Good thought. Well, remember that you are allowed to... Well, okay, let's go back. Wouldn't this be the same as this? Right? Yeah, okay. Okay. All right. Mm-hmm. So, do you know how long this whole thing is? 10, because it's just another radius of the circle. So, if I could just figure out, I don't know, what these pieces are, I could subtract them away. There's a pretty easy way for me to find out what this piece is. Yeah.
Would it be 4 because it goes from 20 to 16? So if it's a circle, which is perfectly the same all the way around, it would be 4 units to that point.
I don't know. You might be right. I don't know, but here's how I would do it. Right triangles, guys. They're your friends. And so are radii. Draw yourself another radius right here. And now look, I just made a new right triangle. And I know that that radius is 10. So that means this has to be 6.
It's not for drawing.
Sorry. Cool. So now I know that that's 6. So now this piece must be 4, right, altogether? That whole thing. So now I just have to figure out, okay, I just need a way to get that piece, which I can do. Actually, I don't need this piece at all, so never mind. I do know that it's 4 altogether, but couldn't I make another right triangle like this? And look at this right triangle. So now this one's 10. I already know the bottom of this is 6. So what's this back one have to be? If that's 6 and that's 10, that's 8. So what's this little piece? 2. So now that's 2, which means this is 2 root 2. I know.
I thought that might.
This one was super hard.
It kind of looked like a 45, 45, 90 triangle.
But I like this one because it uses a lot of tidbits. A radius perpendicular to a chord bisects it, right? Drawing a radius wherever you want. So that's really kind of a big takeaway. Draw a radius to a point where it's going to make you a right triangle. And then we get to use a lot of right triangle stuff. Okay? So I will come back to answering more stuff after I do the 9-5 stuff. Well, finish the chapter stuff, I should say. Who am I kidding? So, if you have more questions, we'll come back to